Hello friends, welcome to my YouTube channel Computer Science Classes by Nikhil Srivastava. So today we will try to understand the concept of a classes and an object. So we will try to understand both of these entities, which are the basic framework of any object oriented programming language. Take for example C++ or Java or C# or any other object oriented programming language. Classes and objects are the very basics. So what is exactly a class and what is exactly an object? So whenever you are asked about a class, so you can say that a class is actually used to represent a real world entity. See, in my next slide, I say that a class is a representation or a blueprint of a real world entity. It is just a representation and has no physical existence. So what does this exactly means? It means that you first of all identify your problem statement. Your problem statement is that you want to represent some real world entity. So what can be some kind of real world entity? For example, I just open a notepad and I just ask you, what can be a real world entity? So a real world entity can be anything. You can think about many real world entities. For example, I can say that a student is a real world entity. I can say that an employee is a real world entity. I can say that a fan, my home fan is also a real world entity. I can say the mobile is also a real world entity, and there can be many number of things. I will just take a few more things, like for example a book. This can also be a real world entity. So my problem statement is that I want to represent these real world entity into my programming language, into my object oriented programming language, and I want to perform some operations on these entities. So I want to represent a student on a computer or through a programming language. So this is my problem statement. So how will I go for it? I will go for it with the help of classes. So what I will do, for example, from the many of these entities, from many of these real world entity, I select one. I suppose I select a student. Then in order to represent a student, I need to design a class. So I need to design a class. And what will be the name of the class? The name of the class will be student. The name of the class will be always student. Over here. So whenever you are asked about real world entities, you just remember two things. Okay. You remember the state of the real world entity and you remember the behavior of the real world entity. What did I say? State and behavior. So over here also, the real world entity is student. So I represented it through a class named student, and now I want to think in terms of the state of student, and then I need to think in terms of behavior of the student. I need to think in these two terms. So whenever you think about state, first of all, let us think about state. Whenever you think about state, you think of some definite kind of variables that can represent student. If it is not clear, then let me say like this. Suppose I say that the student ID is one of the states of student. I say that the name is one of the states of student. I say the email of student is one of its states. I say that his percentage marks is one of his states. So these are there can be many states of student, but these are four states of the student. For example, if I take the student ID, the name, the email, and the percentage. So these are all specific states of the student. Now when I talk about the behavior of the student, so there can be many behavior. For example, a student eats in a specific way. A student, for example, I say walks in a specific way. I say the student dances in a specific way. So these are all the behavior of the student. So remember this very basic important fact of designing object oriented classes. Whenever you design classes, remember this very basic important thing, that you represent the state of a class or of a real world entity through member variables, and you represent the behavior through member functions. Like if you see this slide, I have written that in order to represent the state, you need member variables, and in order to represent the behavior, you need member functions. If still it is not clear, then we will look on to it through a very basic practical example. So let me go to my IDE, and I have my main method over here. But now what I will do is that I will design a class. And what is the name of the class? The name of the class is student. Okay, before that, I have taken student, but I can, for the given case, I can take any real world entity. For example, I can take a fan. A fan is also a real world entity. Then I need to identify the state of the fan. There can be many states of the fan. I need to, suppose I say that the color of the fan, the RPM, that is the rotation per minute of the fan. I can say the motor power. Okay, I can say the cost. These are all the states of not a student. These are the states of fan. And then I need to identify the behavior of fan. Suppose I'm talking about a ceiling fan. Then a fan rotates in a specific way. So I can say rotates. And if you are not clear, this rotates, I can write something like, something like this. I can write a fan rotates. Fan rotates. I can write like this. So in my this entity, when I want to map a fan, the behavior is rotates, and the state is like cost, motor power, color, rotation per minute. All these can be states of the fan. So this is just a kind of very abstract example. It's not a very concrete example. So let us go to the concrete implementation of a class, of how can we represent a class like this. So over here I have taken a class, and what is the name of the class? The name of the class is student. So what I want to do, what is my problem statement? My problem statement is that I want to represent student into my programming language, that is any programming language. For the given example, we are studying C++, so we are representing student in C++ programming language. So first of all, what I need to do is I need to identify the states of students. So what are the state of a student? I say that student ID is one of the state of the student. The student name is one of the state of the student. And for example, I say that that suppose his subject, a student can have subject also. Suppose these are all the three states of the students. These are all the three states of a student. So I'm just taking three states, for example. You can take any number of states. So the student class has three states. And now I need to think in terms of behavior of the student. So what can be a specific behavior of the student? I can write, for example, I can write eat, and I can write like this: cout a student is eating. Or a student can dance also, so I can write something like this also. Suppose a student is dancing. So these are some of the behavior of the student, specific behavior of the student. A student eats in a specific way, a student dances in a specific way. So these are all the specific behavior of the student. So in this way I've represented the student class. So in C++, you remember this very important thing, that whenever your class ends, you terminate a class by a semicolon. Okay, this is something that is specific to C++. So over here I have written this semicolon when my class terminated. Which class? The student class. This class terminated. Okay. So this is basic of a class. So just repeating on the fact these are my two instance functions, member functions, and these three are my member variables. Okay, so now what I'm going to do is that I'm going to design an object of the class. So you must have heard about objects also. So what is an object? So before trying to understand object, one more thing I would like to state. And what is that one thing? If you go to this slide, you will see a class is just a representation and has no actual physical existence. You see, class has no actual physical existence. So what does this exactly means? This means that when I am designing my class, say suppose I am designing my student class, then this class itself, you know, it is not occupying any memory. It is not occupying any memory, and it does not have any actual physical representation. Okay, but it is just, you know, it is not occupying any memory, but it is just a kind of representation, and it is just trying to represent the student. It is just trying to model the student, but actually it has no existence. It has no physical existence. It is just a representation. But when we talk about objects, then objects have actual physical existence. Okay, so if you go to this slide and you just see object, an object is an instance of a class, and objects actual have physical existence. So what does this mean? So we will try to understand this thing little graphically. So what is, tell me, what is the name of the class? The name of the class is student, and I create an object of the class. Suppose the object of the class is S1. So this is very basics of C++. Whenever you want to design an object of the class, you write the name of the class followed by the name of the object itself. Okay, like this. And to make things little simple, I'm going to write the public accessibility modifier over here. Public accessibility, I will explain this in more detail in my coming lectures, but let us be very clear that public accessibility modifier means that all these member variables, these three member variables and these three member functions, or all the member functions and variables of the class, are even accessible outside the class. So here I will write s1.id is equal to, say suppose 1, s1.name is equal to s1.sid. It's not id, it is sid. Suppose s1.name is equal to Nikhil, and s1.subject is equal to, say suppose, theory of computation. Yeah, it is like little big name, so I will just write it small. Suppose Java. All right, let us be little small about it. So so these three are the student S1. So S1 is an object of class student. It is an instance of student. It has its SID 1. It has the name Nikhil, and it is as a subject Java. So what does this mean? So in order to understand this, I will go to the paint, and we'll just try to understand it with this very basic thing through some graphic representation. Suppose it is like this. So over here, so this one see, this object is allocated somewhere in the memory. The name of this object is S1, and this represent the student ID. This represent the student name, and this is gonna represent the subject. Okay, so this object has been allocated somewhere in your inside your memory. Suppose this is the boundary which you are seeing is like suppose a memory, your RAM, and inside this RAM somewhere this object has been allocated. This object, what is the name of this object? The name of this object is S1. The SID is 1. the name is Nikhil and the subject is Java. Alright. So this way, somewhere in memory, this object has been allocated. So one more important thing, let us return to my NetBeans ID. Whenever you access a member variable or member function through an object, you always use the dot operator. For example, here I'm accessing SID, the student ID, through the object S1. So I will use the dot operator. If I want to access the name, then I will use the dot operator. If I want to use the subject, I will use the dot operator. If I want to use even the member functions also, like this, for example, I say S1 dot eat, then also this is a member function, then also I need to use the dot operator. So this is very clear. I'm not going to run this program right now. This is just making you try to understand what is exactly a class and an object and a relationship between a class and an object. But what I'm going to do over here, I'm going to create another object. Suppose this class has another object S2. How can this class has another object? Yeah, this class can have many objects. But what does this in real term means? This in real terms means that suppose you have a class and in that class you have 30 students. That means you will create 30 student objects. Is it clear? You will make 30 student objects. But does that mean you will make 30 student classes? No, you will not make 30 student classes. You will only make one class, and of that one class there will be 30 objects. For example, in this example, we have one student class. See, we have not made 2 or 3 student class. We have just one student class, and in this one student class I have created 2 objects. This is the S1 object and this is the S2 object. And now I can say something like this also. For example, suppose I just copy this and I write it over here and I say to, suppose the name of this student is Nitin and his subject is suppose Android. So what will this mean? This will mean exactly in the same lines. This will mean, for example, this will mean something like this. Yeah. So it will mean that another object, this object name is S2, and this object also has a ID, it has a name and it has a subject. For example, this has an ID of 2, it has name Nitin, and it has subject. What is the subject? It has subject Android. Okay, so if you take this example, this is the student ID, this is the name, and this is the subject. Alright, this is it. So we can also, so this student S2 object is also allocated in the memory, S1 is also allocated in the memory, but they have different copies of ID, name and subject. You can see S1 has the ID of 1, whereas S2 has the ID of 2. S1 has name Nikhil, whereas S2 has name Nitin. So that means every object will have its own copy of member variables. Okay, this is very important concept. You need to, because these are the very basics of object oriented programming. I will just write this very important concept. What is this concept? Every object has its own copy of instance variables. When I say instance variables, that means member variables. So in this case, this means that SID, name and subject, these are all my instance variable or member variables. S1 will have a different copy of SID, name and subject, and S2 will have a different copy of SID, name and subject. See, I am trying to explain these things in little details. Some people who are very conversant with object-oriented programming, they will find these things redundant. But if you are a starter, then I'm trying to explain in the perspective of a starter who is like just starting trying to understand C++ programming language. So S1 has a different ID, name and subject, s2 has a different id, name and subject, and I am also repeating things so that it fixes on your memory, you are clear through it. So I think this statement must be very clear in your mind, that every object has its own copy of instance variables. Okay. So like this. So we have understood the very basics of classes and objects. In my next video, we will try to actually implement a class, and we will try to actually call some instance methods of the class. Okay. Thank you for watching. If you like my video, then please subscribe to my channel. Thank you.